Hello, hello. My sound is audible, no? Hello.
Yes,
Shall
sir.
we start?
Yes,
Yeah,
sir.
audible.
Okay. Okay. Now we'll start the part of the industrial engineering. So last time we have gone through the different types of charts. That is our process charts or outline process charts, then flow process charts, and multiple activity charts. So now we're going to see the industrial engineering next part, that is the string diagram. Last time we have gone through the different flow process charts. After that we have gone through the flow diagrams, and next that is the string diagram. So whenever there is not possible to trace the movement of the man or materials in the shop floors, or sometimes if it is overlapping, then we will go for these string diagrams. Two diagrams are there, that is the flow diagram. This is also used for measurement of movement of man or a material. But this flow and string diagrams, what is actually difference? String diagrams, it is used whenever overlapping movement is there, means from one station to next station, and next stations to third station, and again it is coming back to the fourth station. That cross movement is there. So this type of movement actually we may not trace in this flow diagrams. Under these conditions we are using a string diagrams. So what is actually string diagrams? String diagrams, the scale plan on which movement of an object, man or materials are traced by means of string. One small string is there, and the movement of the man or materials, it can be traced by using the string. The main advantages of string diagrams over the flow diagrams is, this is very important, repetitive movements between workstation which are difficult to trace on the flow diagram. So this is actually difference between our flow diagrams and string diagrams. Repetitive movements between workstations, if it is there, then we cannot use flow diagram, we can use a string diagram. So how to prepare this string diagram? That is very simple things. 4 point they have given. After that we'll take one examples with charts. The first point, the layout of working place is prepared to scale on soft wooden boards. So you can take one wooden boards, and workplace you have to assign. Then second, pins are placed into the board to mark exactly location of the workstation. Small pins or paper pins we can mark on that boards. Pins are driven in such a way that they can use at least 10 to 15 distance apart above these boards. And after driven into that board, third point is the strong threaded is taken tied to the starting point of the pin. So you can make use of string, and there you can wind that string first point of the pin. Then each movement between work center is indicated by lying thread, that is a string, around the corresponding pin in the sequence, and repetitive movements are indicated by laying the threads of string in the layers around the pins, in the threads in the layers around the pins in the vertical plane also. So just you can uh, wind that string to the head of the pin, and as per the movement the string need to move to the next pin, wind there, then you can go to the next. Like this you can make the path of the movement. The distance covered by the objective, either man or material, is obtained by subtracting length of remaining thread from the original length. So easily, if you measure the length of threads which is already traced, the length we can measure. The length of that string or that thread that is equal to the movement of man or materials. The see, this is the diagram, string diagram. The in industry at one corner there is a stores, and at the last corner maybe dispatch section or stock room is there. In between various machines are there. So machine number one, this is workstation. Machine number two is there. Machine number three, four, five, six. So one to six workstations are there. Maybe machines or workstation, and material or man from the store. It will go to the first machine. After that, directly it will go to the third machines. After that, third machines to the fourth machine, and after that it will come back to the second machines. After that, fifth machine, sixth machine, and then dispatch. So this is actually string diagrams, maybe man's or material movements. So main purpose to make such diagrams, see that machine 3, 4, 2, 5, the cross symbols are there. So is it possible to remove this cross? So minimum movement should be there. In order to make that minimum movements, either you can shift a machine 4 in place of 2, or 5 in place of 3, or you can make certain arrangements so that so unnecessary movement of man or material should not be there. This is so simple. So main purpose to study these string diagrams to reduce the movement of man's or material movement from store to the stock out while in the processing. This is the importance of the string diagrams. Okay. Now, so where use of the string diagrams, first it is very simple in dealing with complex movement, plant layout or design problems. So it is simple. Just we can trace that point from workstations to the various workplaces. Second, it is clearly indicate the conjunctions means complicated or overutilized or underutilized path or bottlenecks on the shop floors. Means whatever the problems in the movements are there, that we can get and try to solve that minimum movement should be there. It is actually meaning of the point number second. Third is that it traced the existing path of movement for necessary modification. Means if we want to go for work study, then in this work study, we have to study about the present methods by using these string diagrams, and if possible, you can make the modification so that the material handling cost will get reduced. Then fourth, it shows the patterns of the movements. So when you will be in the management levels, then you will come to know that in which way man or material is moving. So that is it possible to go for modification so that man and materials, the times for the movement it can get saved. It is advantages in studying the movement of one individual operator handling number of work, bench work. Since individual operator study also we can study by using this. A group is moving from one machines or in bench to others. It is useful for testing relative value of different layouts. So in industry, different types of layouts are there: product layout, process layout, flexible layout, shift layout. So many layouts is there. So which layout, which actually particular product it is feasible in production, so that manufacturing cost will get reduced. So with the help of this string diagram, this knowledge will get. Now, what are the disadvantages of this? If movement is curvilinear, suppose curve is there, that man or material it is moving in the curve, then it is very difficult to trace. So it is not exactly possible to trace it on string diagram. No estimation is possible about movement. So only one disadvantages of string diagram is there. Any curve linear movement is there by the man or material, then we cannot trace by using the string diagram. So this is about the string diagrams. Very simple concept is there. Then the next charts, that is the travel charts. So up till now we have gone through the operation process charts, means two operations or three operations. In that, only operation and inspection point is there. After that, we have gone through the flow process charts, multiple activity charts. Then we came to the flow diagrams, team diagrams, and this is one more chart, that is the travel charts. So before going deep into this travel chart, you can see this travel chart. This is the actually travel chart. Now, why there is a need to make the travel charts? So up till now, whatever we have studied about flow diagram and string diagrams, here quantitative data, it is not included. So weight, this is the one of the quantitative data. Then the particulars equipments and particulars objective dimensions or any other things which is related to job which is not mentioned in previous chart, that we have included in these travel charts. A travel charts is tubular record of presenting quantitative data like frequency of movement, means how many movements within few seconds it indicates, weight, distance, the frequency of
Hello.
movement. Hello, hello, hello. Any problem? Hello. It is audible, no?
Yes, sir.
Shall I continue?
Yes.
Okay. Travel charts. So this travel charts actually it including three parts: frequency of movement, weight, or distance related to our jobs in the shop floors, which is not including in string diagrams and flow diagrams. Now here's a objective like man, material, or equipments along the given path over the given period of times. So string diagram is useful when movement of jobs are limited. So this is the uh, limitations related to the uh, travelings in the shop floors, related to the frequency, related to distance, related to weight. But string diagram has the following disadvantages. Already we have seen the some disadvantages of string diagrams, even though for a string diagram certain again disadvantages are there. First, it take longer time to construct. Means in string diagrams, what actually we require? One boards, pins, and string is required. So it will take more time. This is one disadvantages. Second, diagrams look confusions when there are a large number of movement of jobs. Means from stores, if two, three mans or jobs are coming out, and then it is very difficult to trace that point of materials or man. So number of moments are more than these diagrams will get confused. In string diagrams will get confused. Next, it does not indicate quantitative factors like weight. How much weight has gone from the store? It is not included. How much quantity taken by the man from the store to the first machine, second machine, it is not indicated in that diagrams. So therefore, to record movement of an object in exactly complex situation, travel chart is used. So when there is a need to get some quantitative data like a weight, then we require these travel charts, means how much weight has gone from store to first machine, from first machine to the second machine, like this. So weight quantity, this is importance in the travel charts. Now how to make these travel charts? So construction of travel charts, all department or workstation are listed both row wise and column wise. So department wise, all the workstation we can divide into row wise and column wise in the same sequence. Each intersecting box is used to present the data for the movement of the jobs from one station to the next station or another station. Horizontal line represent workstation from which movement of job start. Vertical lines represent workstation at which movement of object end. Starting and ending. The horizontal, that indicate starting point, and vertical points indicate the end points. Starting and end point. Only you have to remember starting and end point. Horizontal lines, it is starting line, or starting point. Vertical, that is the end point. Now let us see one example, which is actually from the industry. A workshop manufacturing three products A, B, C by using manufacturing facility arranged in the departments. One workshop is there and they are manufacturing three products A, B, C. For example, nut, bolt, washer, like this way. Using manufacturing facility arranged in the six departments. So here six department is there: U, V, W, X, Y, and Z. Six department are there. Material handling is done by forklift trucks. So this is the one of the device used in industry to transfer the material from one place to the next place. So this is the forklift trucks which is used in industry. So this is used for material handling. Each time truck can carry 100, 200, and 300 pieces of product A, B, C. Means one times it can handle the product 100, 200, and 300 pieces of A, B, C respectively. Means A can handle 100, B 200, and C 300 each time. Okay. The annual demand of each product is 9,000 numbers. The sequence of operations are like this. So this is one example. One industry is there, and in that industry, they are manufacturing three product A, B, C, and six departments are there, and they are using material handling like forklift trucks. Each time that trucks can carry 100, 200, and 300 pieces of ABC. Annual demand of each product to be handled, that is the 9,000. The sequence of operation as given below. So left side product A, B, C, and sequence is there from each departments: U, W, Y, Z, V, and X. This is the sequence. For A, one sequence is there. For B sequence is there. C sequence is there. Now, how to construct the travel chart? This idea it is given here. Point number one, as there are six departments, U to Z, travel chart is drawn with six small square cross U to Z from left to right. So here you can make the small squares from left to right. How many numbers are there? Six. Six small square drawn again, title A to Z, and thus there are total 36. Means that you can make six horizontal and six vertical rows and columns, six. So total 36 square will be there. Then second, the column headwise square, that is square from left to right along the top chart, represent the sent department from which movements are made. From which department the product has said, that has been noted. The square recorded headwise, the square from top to bottom, the chart represent department wise to which the movements are made. So so in vertical line, department is there, horizontal lines, the movement is there. So it indicates this one. Movement has been started from the top, from the square of the department from which movement is made, and moving vertical down in the column to square. The product forklift trucks for product A, then there will be 9,000 divided by Hello, the screen is visible or not?
Yes, sir, visible.
Okay. So once again, this travel charts, as per our these problems, this is example number 22.1. Three products are there, and the quantity produced 100, 200, 300, and that is carried by the forklift. Annual demand is 9,000. Accordingly, we are making this travel chart. So B part, now we reached to B parts. UV. So UV, this we have to mark. So what is the quantity for B? 9,000 divided by 200 means how much it is? 45. Means B is the 45 and sequence is U to V. So let us see these diagrams. U to V. Okay. So U to V, this is the 45. So similarly, as per the given sequence, this is sequence V to W. So see that V to W, V to W, V45. V to W, V45 is there. So similarly, you can mark in the each square related to this product A, B, C. Then after this, you can count the horizontal, the quantity. For first row, horizontal quantity is 30. Second row, horizontal quantity is 75. Then 165, 135, 210, and 120. Means this is the additions of the quantity row wise. Similarly, you can go in column wise 165, 165, 165, 75, 90, and 45. So from this chart, traveling chart, which sequence you have to make use for optimization, this thing you will get from the travel chart. For example, 210 is there. So how much quantity it is actually travels through this, that is 210. Now, is it possible to make the reduction in the 210 and we can adjust somewhere? Similarly, in the column wise 165, that is the highest quantity. Now, is it possible to adjust in the 75 column, 90 or 45 column, so that this traveling it should be optimum? So main purpose of this travel charts to travels in optimum way in the shop floors, and this graphical representations, it is shown like this way. This is called traveling chart. So you can remember this example and the chart. It is so simple sequence you have to put here, and at last you can go for addition of the all value and you can put at the right hand side. After that vertical, all this value you can go for additions and you can write at the bottom. And from the charts we have to think where we can go for optimizations in these travel charts. So first, present methods in industry you have to study. Make that present methods presentations about the traveling charts on the papers, and then you can take the decision how we can go for optimum traveling, so that the traveling cost, manufacturing cost will get reduced, increase the production and productivity. This is the main purpose of the travel charts. Okay, now we will go to the next template and models. So this two things are very different. What is template and what is models? So first we'll try to understand what is the template and what is the models. So I will give one example. Template. Now in sugar industry, if you visited to sugar industry, then you can see that the various type of flats are there. Maybe bagasse carrier slat or cane carrier slats. It is there. But while manufacturing, as per the drawing, in order to check that by using attribute types of inspection, we required certain templates, certain gauging system, and the workers used to gauge the manufacturing part or this slat or the bagasse carrier or cane carrier slat by using template. Means whatever the existing product is there, accordingly we have to make the same product for measurement purpose, and we have to check that. And model means the that is the you know, what we call that is the models, or what is that statue, or the similar things you have to make with less costly material. For example, I want to manufacture cylindrical liners, okay, but I have designed that liner in different way. So before manufacturing, what should be the size of the liners, bore of the liner, length of liners, that we have to visualize by making the same liners with low costly materials, and you can use for this making the models for prototype things for testing purpose also. So this is actually difference between template and models. So here flow diagram, string diagram shows the movement of man and machines by drawing scale plan shop floors, but do not indicate any conjunction or bottlenecks. These problems are better visualized by using template and model. So what are the disadvantages of the other charts are there, problems of other charts are there, conjunctions of the other charts are there, bottlenecks of other charts are there. These things we can overcome by using a templates or models. So what is template? Here it is given. Templates are two-dimensional cutout of cardboards or colored papers, and they are prepared with a scale. Scale must be there, and are placed on the scale plane of building drawing on board or graph papers. Template shows plan of various facilities like machine tools, fitting, and storage racks. So here some example is given, but you can remember the slat of the sugar industry, maybe cane carriers or bagasse carrier. In order to manufacture this, we have to make same thing for measurement purpose, not a product. So this is the meaning of this. Otherwise, you can remember the template shows plan of various facility. Like so, suppose you want to manufacture machine tool part, so you have to make template. Suppose you have to make a cylindrical round shape job, just like cam. So initially you have to make the cams from less costly materials, and we can go for measurement of actually manufactured cam, fitting purpose, store racks, etc. In order to check these parts, we have to re replica, what we'll say, the replica of the product to be manufactured. This comes under the a template for measurement purpose. And model that is different. Model means exactly similar part, but we cannot use this part for assembly or whatever the purpose of that product is there. For example, gear is there, spur gear is there, planetary gear is there, so worm gear is there. So before manufacturing that gears, small gears from wooden we can make on our milling machines. Okay, and once that dimension part it will get okay, then we will go for actual production. Means before going actual production, we required models, and in the manufacturing to check that part we required a template. So this is the actually difference between templates and models. Next, advantages of template and models or diagrams. What are the advantages of this template and models over the diagrams, stick diagram, flow diagrams? Okay, so first point, the conjunction bottlenecks can be better visualized. Means whatever conjunctions thing it is going in the shop floors, problems it is going in the shop floor. Bottlenecks means the drastic problems in the shop floors can be better visualized. Now, second, they can be moved on graph paper, thus providing various layout options. Usually, photographs of each layout is taken before preparing another layout. And suppose you want to make the layout for new industry, maybe product layout or process layout or any other layout, you can make on the papers, and due to this trial and error methods, we can finalize which is the best layout. For this purpose, we can use template or models. Third point, it saves the time otherwise which is spent in preparing each layout in diagram. Means if you directly go for layout, it will become costly and sometimes mistake will happens, and it is very costly and time consuming. So before going to the final layout, we can make use of these templates or models, or before going to the final product, you can make use of template and models. So template and models not only layout but for product also we can use. Okay. Limitation of this: overhead facility cannot be visualized. Overheads means the crane is there. Crane is actually overhead facility. So in this template or models, we cannot say this thing. The second, non-technical person find difficult to understand. So workers are there, not any technical background, not IT diploma holders. They cannot understand. This is the problem of this template or models. Now here three-dimensional models. They are the scale models of facility reassembly the actually in the length, width, and height. Means models actually three-dimensional. Means before manufacturing any parts, for example, a statue of Shivaji. Okay, before manufacturing, you can put on the paper height, width, and other three-dimensional things, and then we can go for actually manufacturing. Same thing is there. They are made up of wooden or plastic. So here we can use wooden, plastic, or paper or any other less costly material before making the final product. Means we have to make the model. Normally we are calling you make the models and then we can manufacture, because any mistake is there in the manufacturing, any mistake is there in the dimension, any mistake in there in the in the visualized point of view, that will get opens if we make the models of the any other part. They show the less detail compared to physical facility. The models are commonly used to prepare floor plans or elevations, and they are very useful to prepare floor plans and elevation. So while making the layout, we can use this. They are very useful while preparing alternative plans for multi-store plant, example, three-dimensional models of chemical factory or refinery. Now, this is not only for chemical factory refinery, you make use of for any product. So if you are manufacturing cylinder, you can make the models. If you are manufacturing slat, similar models you can make. If you are manufacturing bearing, similar bearing with less costly material, we can manufacture. If you are making layout on the shop floor, similar layout with less costly, you can make on the paper. So because of this, it is a less possibility to get commit mistake in the manufacturing. Next. Some advantages of this: non-technical person find it easy to understand. Means if the model is there, then the non-technical person can understand. Overhead facility can be shown. So means in the models, whatever crane facilities there, elevation parts are there, we can see it. Now, disadvantages related to models. Now, third, service facility like lighting, ventilation, safety features can be easily shown. Means if you want to show any other facility in your layout, we can show in these models. Light may be there, ventilations, safety features we can show. In case of jobs where we require central relays, where is the burst? where is the small jumpers, how much spinach is there. So like this, we can visualize in the models also. Model can be easily shifted, means we can shift in the manufacturing, or we can change if there is a problem in the real situation. Therefore, comparison of alternative layout is more easy if we real situation, means real product manufacturing. This model it shows the. Now, what is the limitation of this model? They are expensive. If you are using, they are very expensive, and little bit time is required to manufacture this. Difficulty to be taken for this site for reference. Now, sometimes if the this plan is a very big, then it is very difficult to take these parts to the site where actually this type of layout is required. So this is about the travels and models. Once again, we'll go back and see that what is the template and model. Template, it is similar part. This is also called two-dimensional part, and it is actually used for measurement purpose before finalizing the final component. Here I have given two examples, that slat which is used in industry, and models actually replica of the part to be manufacturing. Okay, our pattern is actually models to be what actually casting will going to manufacture. So pattern also we can call some models, and the cast product, that is final product. If there is a problems in the final product, then the whatever models you have made, that in that model might be certain problems. Okay, so template we can use measurement purpose. This is two dimensionals. Models actually replica of the component to be produced. And what are the advantages or disadvantages of this? It is actually I have shown here. Okay, now next point is their photographic ads. Now this point it is not in our syllabus, but even though from the gate point of view, what is the actually importance of the photograph? Sometimes the question will be, that's why I have taken this. In case of detailed investigation of workplace where operation is of short duration or performs at very high speed, or different jobs are performed simultaneously, observer is unable to prepare the movement accurately enough for recording purpose. In such case, photographs ads can be used for this purpose. Now, photographics help. This is the one of things in industrial engineering. Sometimes at a time, same jobs are manufactured or manufacture jobs with high speed. It is very critical to measure the movement dimension in the process. Under this condition, we require photographic helps to decide the uh, job movement, job weight, okay, and the traveling of the jobs. Okay, so this actually we require photographs with a slow motion, just pictures. Actually, this part is not in syllabus, but you have to remember where we can use photograph. We can use photograph where high speed is there. Different jobs are performed simultaneously. Means bearing, so many bearings manufactured at same time. Then we can use photograph. It is very difficult to observe. Under that condition, we can use this photographic ads. What are advantages of this? It can be recorded permanently for further use, because we are using here camera, so we can use in the future, and we can store it permanently. Record can be used at any times, at any place by number of people. Means once it is cached in camera, we can use in future also. Differences can be presented very well. Reproduction of original method is possible at any time. Sometimes problems in the future manufactures or in a new methods, then we can reproduce the same thing. For this purpose also we can use repetitive study of workers movement. It is possible without this. Suppose You want to study about the repetitive motion of the workers. Means your study is going in the one shop floors and you are studying about the what actual worker is doing, what is actually unnecessary activity that done by that worker, and how to find out this. This also we can judge by using of photography. Then advantages of cine film. Sometimes film is also required for this photographic study. They can be projected at any required speed and can be stopped at connection. So just like our film, we can produce the film and we can project on the projectors and we can see by slow motion and stop at any place and we can find out the problems. They can be run backward also. We can move backward, forward, anything we can do. Provides greater accuracy than watching technique. Watching technique is just in work measurement. Here you will get more accuracy about study by using this cine films, and they are more convenient also. So video of camera also we can use for this. Nowadays it is very feasible by using our mobile system also. So we can but I don't know whether it is possible to record the movement of the man or material in the slow motion in the mobiles. If this thing is in mobiles, we can use the mobile for this. So, what is the use of photography in industrial engineering? Like these questions may be in GATE, but at this point it is not in our syllabus. From GATE point of view, you have to remember this. Now, next point, that is the micro motion study. So micro motion study uh, in industry, so many jobs are there, and we have to study about the different types of motions while doing the work by the operators on that workplace, and while doing which is the unnecessary motions that easily we cannot detect by using our naked eye. So here we require certain once again camera, and we can put this camera after this study in the slow motions, and which is the um, unwanted activity, unwanted motions that we have to study by using micro motion study. So here some concept it is given. Many repetitive operation of short cycle like component assembly. Many repetitive operation of short cycle like component assembly. Suppose you are making the assembly of cylinders and liners, the assembly is going. So what activities are there which are repetitive active? Why there is need to go for repetitive active? So by using this study, we can avoid that repetitive activity. But here, by using this micro motion study, we have to find out the repetitive activity in the present, the assembly or present shops, packaging, inspection, then separations of fixed jobs, clerical operation. Some one clerk is there. What is actually repetitive action of the clerk? He is opening and closing the door. So this table door is there. Many times we have observed that clerk always used to open and close that door. So this is actually repetitive action. So how we can reduce this activity? This thing will get by using micro motions. Now, quick movement of hands, which can be accurately studied by using operation part, such as two-handed procedures. So actually, we have seen in the this two-handed process chart, the any assembly parts or any two parts assembly we can do by using the two hands, left and right hand. And there should not be idleness. There should not be repetitive movement. This thing actually we can do under this micro motion study. In certain types of operation which are repetitive thousands of times, such operations better to do the detailed study of such operation to determine whether movements or efforts can be saved to develop the best possible movement, which will enable operator to perform repetitive jobs, which is a less fatigue. Means many times unnecessary activity is actually happening in the shop floors, and that is in micron, very small. It is very difficult to understand or observe such activity. We can note it under the micro motion study. And some while doing this thing, we can think about any fatigue to the operators or not. Micro motion study analysis is expensive to conduct, therefore it should be applied only if it is used justify the investment. So because of the lot of the devices actually we required, and to study about this small activity, we are we actually required more times, and we are going in this path. It is more time wasting part, so that always we can think whenever actually requirement is there micro motions, only in that position we can use the micro motion study. Very small motions we can understand under this. So here it is actually 3:30. So shall we stop here? Hello, our time is over. Shall we stop here?
Yes, sir.
Hello.
Yes, sir.
Okay. So I have noted your presentee by screenshot. No problems. Again, tomorrow we'll going to see this part related to micro motions. Anybody having any problems related to this? What actually I covered up till now? Yes. Anybody having any problems
No, sir. No, sir.
related to things? What actually I have? It is okay, no? Okay. We'll stop here.